Hello, myself Aditya Agrawal. My class is BSc third year and my group is BTZ and my topic is organometallic compound. Introduction. There is a definition of organometallic compound are those in which there is a metal carbon bond or carbon is directly bonded towards the metal. Usually, organometallic compound are those who comprise not only a compound of a typical metal but also a metalloid such as boron, silicon, phosphorus, arsenic, psyllium, etc. Next, there is the ionic character. There is the ionic character. The carbon metal bond in organometallic compound are ionic, and the extent of the ionic character of CM bond depends on the electropositive nature of the metal. More the electropositivity of the metal, more is the ionic character of the metal carbon metal bond. There are some examples of carbon metal bonds. There is a CK bond is a 51 percentage. There is a C and A bond is a 47 percentage. CLI bond is a 43 percentage. CMG is a 35 percentage. CZN bond is a 18 percentage. CCD is a 15 percentage. CCU bond is a 9 percentage. And there is a reactivity of organometallic compound depends upon the ionic character of the carbon metal bond. The more is the ionic character of carbon metal bond, more will be the reactivity of organometallic compound. Thus, there is a highly ionic compound such as organosodium or organopotassium compound are amongst the most reactive organometallic strength. And and the other hand, there is a less ionic compound like a tetrahedral lead or dimethylene mercury are far less reactive. Reactivity is stable in the air, volatile and soluble in non-polar solvent like a hydrocarbon and ether. Next, there is an organometallic compound. An organic compound containing carbon metal bond. There is a two most common types. There's organolithium compound and organomagnesium compound. Organolithium compound are those compound the the atom to of the hydrocarbon group is directly bonded to the lithium metal, and the organomagnesium compound are firstly discovered by the Victor Grignard of organomagnesium halide. There's a alkyl group with magnesium and halide bonded are the Grignard reagent. The Grignard reagent are the most important reagent by the virtue of their significant and a wide application. Most of the organic compound of all the classes can be synthesized from the Grignard reagent. There is a Grignard won one half of Nobel Prize in 1912. Then next is a preparation of organomagnesium compound is a cyclohexyl bromide is directly added to the magnesium in the presence of the diethyl ether to form the cyclohexyl magnesium bromide. There is another example is a vinyl bromide. As a vinyl bromide in the presence of the magnesium in the presence of the THF to form the vinyl magnesium bromide. Next, there's another example. There's a organomagnesium bromide react as if it is where is a ethylene negative and a magnesium bromide positive charge. The phenyl lithium is also react if where phenyl negative lithium positive. There are also another examples also here. Next, there's alkyl halide, vinyl halide, and aryl halide can all be used to form a organolithium and organomagnesium compound. However, this organometallic compound cannot be prepared from the compound containing acidic group, just as OH, NH2, There is so example it is C. Formation of organometallic reagent. Many of the organometallic reagents are commercially available, however, it is often necessary to make them. The following equation illustrate this reaction for the commonly used metal lithium and magnesium. And the reactions an alkyl lithium reagent. This tertiary halide is added in the lithium compound to form the tertiary lithium plus lithium halide. And another is a reagent and another is a reaction is a Grignard reagent. Grignard reagent also the tertiary halide is directly bonded to the magnesium to form the tertiary magnesium bromide. Next, these reactions are obviously substitution reaction, but they cannot be classified as nucleophilic substitution as were the earlier reaction of alkyl halide because of the function carbon and carbon atom has been reduces. The priority of the resulting functional group is inverted. These changes as shown below make a alkyl lithium and Grignard reagent excellent nucleophiles and useful reactant in synthesis. There is a reaction is a alkyl halide or tertiary halide is directly bonded to the active metal just like lithium, magnesium, zinc, etc. to form the organometal. Organometal. These are the tertiary metal. Next, there is an example of the reaction. Methyl bromide is directly converted into the magnesium in the presence of ether to form the methyl magnesium bromide, and the another is a methyl iodide is directly bonded to the lithium in the presence of hexane to form the methyl lithium. Next point is a common organometallic reagent is a methyl lithium, butyl lithium, tertiary butyl lithium, phenyl lithium. Next, methyl magnesium bromide, phenyl magnesium bromide. Reaction of organometallic reagent with the various carbonate. Because of the organometallic reagent react as their corresponding carbanion, they are excellent nucleophile. The basic reaction involves the nucleophilic attack to the carbanionic carbon in the organometallic reagent with the electrophilic carbon in the carbonyl to form the alcohol. Reaction is halide is react with the alkyl magnesium halide in the presence of ether or alkyl lithium in the presence of ether in all the presence of the H3O positive to form the alcohol. It's a primary alcohol. Both Grignard and organolithium reagent will perform this reaction. Next. Addition of formaldehyde gives primary alcohol. That's a reaction is formaldehyde is react with the alkyl magnesium bromide or alkyl lithium in the presence of H3O positive to form the primary alcohol. And the next one is reaction is a aldehyde group. This react with the alkyl magnesium bromide or alkyl lithium in the presence of H3O positive to form the secondary alcohol. The next reaction is the addition of ketone gives tertiary alcohol. The ketone is react with the alkyl magnesium bromide or alkyl lithium in the presence of H3O positive to form the tertiary alcohol. Next, addition to carbon dioxide to form the carboxylic acid. Carbon dioxide react with the alkyl magnesium bromide or alkyl lithium in the presence of H3O positive to give the carboxylic acid. There is some example. Formaldehyde is reacted with the phenyl magnesium bromide in the presence of ether and the H3O positive to perform the primary alcohol. And the next reaction is aldehyde is in the presence of methyl lithium in the presence of hexane and H3O positive to form the secondary alcohol. Next, ketone is reacted with the methyl lithium in the presence of hexane and H3O positive to form the tertiary alcohol. And the next reaction is a phenyl magnesium bromide react with the carbon dioxide in the presence of ether and H3O positive to form the carbon dioxide so, sorry carboxylic acid. Going from the reactant to the product simplifies the short. There is aldehyde is react with the group with a change CO bond double bond to the single bond converted. There is a aldehyde group is converted, C double O bond is converted into CO negative, and it's reacted with the alkyl group. Add in the alkyl group from the organometallic reagent and the hydrogen to the oxygen to form the alcohol. It's a primary alcohol, secondary or tertiary alcohol form. Next, mechanism of for the addition of carbonyl. The mechanism for the Grignard agent is shown. The mechanism or the organometallic reagent is the same. The nucleophilic attack of the aldehyde group react with the alkyl magnesium halide to form the alkyl C alkyl carbonyl negative and magnesium bromide is positive charge given. And the next is a protonation. There's a protonation of the alkyl carbonyl. It's reacted with the H3O positive to form the alcohol and the water molecule is formed. And the next, there is a organometallic reagent as a base. That's not a These reagents are very strong bases. Their pK of a saturated hydrocarbons range from 42 to 50. Although not usually done with the Grignard reagent, organolithium reagent can be used as a strong base. Both Grignard reagent and the organolithium reagent react with the water to form the corresponding hydrocarbon. This is why so much care is needed in ensure dry glasses and solvent when working with the organometallic reagent. There's a reaction of the methyl lithium react with the water molecule to form the methane, and the LiOH is a lithium halide. Next, in fact, the reactivity of the Grignard reagent and the organolithium reagent can be exploited to create a new method for the conversion of halogens to the corresponding hydrocarbon. The halogen is converted to the organometallic reagent and then subsequently react with the water molecule to form the alkane. There is a alkyl halides. It's react with the magnesium in the presence of ether or lithium in the presence of hexane and H2O molecule to form the methane. Next, thank you for listening.